Hello, how are you doing? It seems that you are a bit overwhelmed with the depth and the intensity of the topics that were covered last week. And if you're feeling like that, don't worry, it's pretty normal because blockchain is a very complex topic. It's a highly evolving topic. And to make your job to absorb things a little bit more easily, I have created a recap of, of some of the main topics discussed earlier, and this will probably also help you to connect it with the topics that will be discussed in the next week. So, this is the recap of the first three classes. So, we started with discussing about the state of our financial situation and our of the global financial situation currently. And we discussed the problems that he has, and then we explored that if Bitcoin could actually be an alternative or a solution here. Now, after that, we spoke about Bitcoin and the we spoke about the Bitcoin's main blockchain, its characteristics, why Bitcoin has the certain amount of block time, that is 10 minutes, why it has a fixed capacity of 1 megabytes, in order to make sure that the entire blockchain is not so big, not so bloated. But we also discussed that puts a limitation on Bitcoin in terms of number of transactions that can be included every 10-minute period, which means the Bitcoin blockchain is not meant to scale up rapidly. And that's why we mentioned that there is this Lightning Network, which is actually connecting to the main blockchain, but not storing all of the transactions. So this is allowing for very fast and rapid payments to happen, while the security of the network is guaranteed by the core of the Bitcoin's blockchain. So, in the next session, we have a session on innovations on Bitcoin where I'll go a little bit deeper on how exactly the Lightning Network works. You now already have a good technical understanding on the Bitcoin's main layer. And then I mentioned that when you are creating a wallet, your Bitcoin uses something known as the UTXO model, that is unspent transaction output model, which means every public-private key that pair that you have, that can only be used once. So each time you spend from a particular wallet address, because a wallet address comprises of public private key, you need to spend the whole output so that the change goes to the next wallet address. And that's why any wallet software that you use will allow you to have an infinite number of public private key pairs, so that you can continue using and spending and using and spending. So each time, if you're using a Bitcoin wallet, you will need to create a new public key. So each time you want to receive a money from someone, you will need to create a new public key, which has its associated private key pair, which will be needed to spend that funds. Now, I also explained that all of this is managed under the hood by most wallet softwares. So all you need to do is when you create a new wallet in Bitcoin is to just remember 12 or 24 words. It depends on what configuration the wallet is using. Some will allow you the option, some will only be limited to 12 words or 24 words. But using the BIP39 standard, all the public-private key pairs can be created. Now, this will become more clear when you actually start using this Bitcoin here. So as I told you, if you buy a wallet, like this is a Trezor One wallet, initially when you start and initialize the wallet, you will be given these 24 words. You note them down carefully, and this is all that you need to recreate it anytime you want. There is another wallet that I would recommend. It's a cheap wallet. Both of these are very cheap wallets. Uh, this wallet Trezor One allows you to have Bitcoin, Ethereum, and some of the major currencies, but it doesn't allow for all of the currencies, all of the tokens that are existing. So if you want to limit yourself only to Bitcoin and some of the major currencies like Ethereum, this is fine. Otherwise, you can buy Ledger Nano S, and this allows you to store almost any cryptocurrency, any token that has been created. So if you want more versatility, probably Ledger Nano S could be something that I would definitely recommend you to buy. But even before you buy something, you can use a free wallet called Exodus. So all of these wallets are non-custodial wallets. That means these wallets, you are holding the seed phrase yourself. So you have the seed phrase. So your coins are in your own custody. This is very important, okay, for your security. Suppose if you use something like the app of a Coinbase, it's very different because the private keys of your wallet are held by Coinbase itself. They may give you a password. So one thing I would recommend you is, even if you don't have your own hardware wallet now, just to test, you can download this software, the Exodus software. I'll just show you how it looks like. So because I already have it installed on my computer, but you can download and see it. So I'm opening here the Exodus app. So once you set up the app, it will initially, you can set up a password, but this password is only there on the app on your computer. It is not being stored on the blockchain. What is critical are the 12 or 24 word seed phrases, which when the first time you initialize, it is already randomly choosing to for you. So here, if I go uh, and here if I go and select assets, you see it is showing me that it's showing me all the various different hundreds and thousands of coins that exist in the world. But all I'm interested right now is in Bitcoin. So when I select BTC, so it's showing me here my BTC balance. So I have 0.00000602. So this is also read as 602 Satoshis. So I have 602 Satoshis in my wallet currently. Now, anytime I want to receive a coin, if I want to receive Bitcoin, at the so this is working at the base layer of Bitcoin. This is not working at the lightning layer. This will lightning uh, the lightning network we will cover later. But at the base core blockchain itself, when I want to receive, I just click on receive, and it's showing me my Bitcoin address. So this Bitcoin address is actually the public key of the address. Okay. Now I can copy this. I can copy it to and send it to anyone whom I want to send it to. I can open my chat or whatever, or on an email, send it to the person and say that if you want to pay me at this address. This is my public address. Okay, because so this is my public key. The private key is kept hidden. And as I explained you, once I receive money in this, next time when I click on receive, it will show me a different address. Right now it's showing me the same address, but once this is already used up, it for instance, if you see, I have received money, but after receiving money on a particular address, next time when you click, it will show you a different public key, because as I told you, an infinite number of public private key pairs can be created. Now when you want to send money, it's a very simplistic wallet. So when you want to send money, you can paste that Bitcoin address you want to send it to. This is currently my own address, but it doesn't matter. And then here you can say how many Bitcoins you want to send. When you click when you put a number here, it's selecting Bitcoin network fee. So this is actually the tip that it is recommending me to put. So this is a fee about $1. It is recommending me to put that network fee. But because Exodus Wallet is a software that is designed for people not who are not, even if you're not too experienced, so it doesn't have all the detailed settings and so on. So you cannot adjust the fee. It is choosing a fee for you so that the transaction can go quite fast. Maybe in 1 or 2 blocks, your transaction will be included. So it's suggesting you this fee. But there are other softwares which can allow you to customize the fee so that you may choose that, okay, it's okay for me. I want to spend less fee. I don't mind even if it goes in one day. Then you can customize your fee. So that's all there is to know on using this wallet for Bitcoin. Okay. And here, if I go on the on the on the settings here, and if I go on my backup option, I can see the 12-word recovery phrase. So I told you there are 12 seed words or 24 seed words. So if I click here, it and it's going to be asking my password that I have initially set. Now it is going to show me those 12 words with which I can always recreate this wallet. So it's showing me marble, smart, play, also panther, vapor, stable, crisp, behind, hidden, egg, and wash. So I've told you all my 12 words. If you recreate these 12 words, if you go and put these 12 words, and whether you use Exodus software or you use any other software, you will recreate my entire wallet. So you can steal all my funds. Thankfully, I don't have much there. So this is how it works here. You can play along with it. Now, this Exodus allows you to use multiple coins. So Bitcoin is not the only one. So the other network, the other platform we discussed was Ethereum. Now, Ethereum doesn't use a UTXO model. That means in the case of Ethereum, you can keep reusing the same address over and over again. So if I want to receive, it's showing me my Ethereum address, and this address can be reused again and again. So if I click this button here, view on blockchain, then in the blockchain explorer, it is showing me this is my Ethereum address, this is my balance, and it'll even show you the history of all transactions. I have not received anything, so this is a virgin address. But on the blockchain explorer, you can see the all the transactions received, sent, and this is the same for Bitcoin as well as Ethereum. So because these are all public blockchains, everything is publicly available. The big difference between Ethereum and Bitcoin is in the case of Bitcoin, because it uses the UTXO model, so you are changing your public key each time you're receiving. Okay. In the case of Ethereum, you can just stay with one address. It's not so good for privacy, but you can stay with that one address and you can keep receiving in that address. And it's the same for sending. You can again put the address, but I'm putting a Bitcoin address, so it's telling you it's not properly formatted. Why? Because it's beginning with the BC1. BC1 is a Bitcoin address, and Ethereum addresses are starting with 0x, and so that's one of the way each blockchain has its own protocol and address terminology. So my suggestion to you is become familiar. At least you can install Exodus wallet. But Ethereum allows you other capabilities like smart contract capabilities. So the next session that you will have on DeFi, you will be actually seeing the advanced functionalities over the Ethereum network. What can be done? Now, bear in mind what the functionalities that Ethereum have. There are several other networks, Binance, Cardano, Solana. They also have the same functionality as Ethereum, but they have lesser fees. So I'm going to be now in the recap going over, I'll be going over all these other blockchains also. So let us go back to the recap that because now that you have a demonstration of the Exodus wallet. So what else did we discuss last time? Last time we discussed how the very fundamental, this is very, very important. I spoke about the blockchain trilemma, and I explained why Bitcoin chose to be very secure, very decentralized, but that means it needs to put a lot of limitations limitations on its blockchain size, which means it is not designed for scalability. And in general, blockchain compared to any centralized database will have that limitation, because the more you decentralize, the more you want different nodes to have this copy of the same network, because that makes it more decentralized, more secure. But that means you won't be able to scale things. So it's never a good idea, even for enterprise blockchains, to store large data, store files, store images, store videos. These are never stored in the blockchain. In fact, this will be discussed later, that you can store the cryptographic hash of these files. You can store hash of a image, or a hash of a video. If you remember SHA-256 algorithm, that's the hash function, because then you will be storing only a 256 character word in the blockchain. So you never store a big amount of information. But even then, to make it extremely decentralized, Bitcoin has this parameter. Now, Ethereum is somewhere in the middle, and Solana is one of the most scalable blockchains. And there are tons of blockchains. Each of them have their own particular characteristics. But the more scalable they are, the less nodes they have, the more they start looking more and more like a centralized system, because usually it's just few parties. Like in the case of Solana, it's a very few nodes, very large, high capacity nodes that are being run, and often these nodes are being run by uh, entities affiliated to the same company. So it's much more centralized. Okay, so this is very critical. Now, I spoke about proof of work and how it is using energy, but that energy provides Bitcoin network the security. But Ethereum also, when it started, was using proof of work. But now Ethereum has moved to proof of stake. I also told about the risks with proof of stake, because what is proof of stake? It means that if you have enough coins and you lock your coins, so different people on the network can pool together their coins and make a staking pool. Okay, so these staking pools then get the right to write the next block of transactions. Exactly how mining works in the Bitcoin space. So this it's in here, these staking pools get the right, and the probability. So there's an algorithm here. So their probability of winning the chance to make the next write the next block increases if they have more coins staked. So that means if you are very rich in Ethereum, you will start earning passive income, and that was already explained by Thomas as to how you can earn passive income on Ethereum, because it has a proof of stake protocol. But this passive income is partly generated by new coins created every time there is a transaction, and partly by transaction fees. Okay. Now, this you will see across different networks. It's not only Ethereum. Proof of stake, in fact, all of the networks that were or smart contract platforms that exist today. So other than Bitcoin, Litecoin, um, uh, everything else is on using proof of stake. Here in this, there is an error here, not really an error, but here Ethereum is mentioned as proof of work. Will be moving to proof of stake, because this is an old table and I haven't yet changed it. I should have done that, but I just realized it now. Ethereum has already moved to proof of stake, but all other blockchains are already proof of stake. Proof of authority blockchains are only enterprise blockchains, which will be explored more when we talk about enterprise blockchains or blockchains used by companies and so on. So these are the three basic algorithms. Now, let me do a recap of Ethereum. So the Ethereum blockchain, it arose because Bitcoin blockchain was not really suited for other purposes. Bitcoin's only purpose is to be a secure money, decentralized money for the world. But if you want to do things like you want to create your own coin, you want to create your own token, you couldn't do it on the Bitcoin core blockchain. You could take Bitcoin and you could create a copy of Bitcoin, but then now you need to convince different nodes and miners to run that network, which is very hard. And then you could create your own version of the coins. That's how Litecoin, that's how many other coins were created. But all of them eventually lost a lot of value. They couldn't hold on to their value. So now Vitalik Buterin decided that let me create Ethereum, and called it the world's supercomputer, or the world's computer. That's what he called Ethereum. So so the advantage on Ethereum is that you can do other things, like you can create tokens, you can create dApps, you can create other functionalities. So let me go over it again one by one to recap. So Ethereum has its own coin called ETH. So ETH is the coin which is used every time someone does any function on Ethereum. Suppose he's creating a smart contract, or he's making a transaction. All those transactions need to be paid in ETH. That is the native currency of Ethereum blockchain. So all of these blockchain projects, the way they work, other than Bitcoin, all of them, the way they work is that initially they create a certain number of ETH. Okay, they even as a they write a white paper, and they sell them to the market to receive some other currency which has some value, because ETH, when it was created, didn't have any value. It was only sold to the market, almost like how an IPO works. So that's called an ICO. So then Ethereum was one of the very successful projects. They built it, and now Ethereum Foundation is managing the project. And uh, what the main functionality on Ethereum is that you can create any fungible token that is known as ERC20 standard, or you can create a non-fungible token, which in technical terminology of Ethereum is known as ERC721. So this means fungible means you can create many tokens. I can create 100 tokens, 1,000 tokens, million tokens, and all of these tokens are fungible, means one can be exchanged for the other. And non-fungible tokens, or NFTs, those are something which is very unique. They represent something unique. So we had this discussion in the class during the third lecture by Thomas, that about difference between fungible and non-fungible token. So Ethereum allows anyone to create these kinds of tokens on top, which means you can choose what functionality these tokens will have. It can be a stable coin, or it can be a token for your project and an ICO. It can represent stocks, it can represent shares, it can represent bonds, it can represent whatever you want. And similarly, non-fungible, it can represent items in games, it can represent art, it can represent whatever you want. So the Ethereum allows this capability to create new tokens. And not, when you create a token, you basically use the smart contract functionality. Smart contract is having a contract in code. So one of the ways you can utilize these contracts, so this is using the Solidity language. If you're interested in learning how to create smart contracts in Ethereum and Ethereum compatible blockchains, you need to learn Solidity. Okay, so Solidity language allows for creating of tokens. It's one function. And when you create a token, you can decide things like how many tokens do I want to create? Okay, I want to create 1 million token. What should be the rate at which the tokens increase? What should be the monetary policy of those tokens? Okay, can it be deflationary? You can have deflationary tokens. You can have tokens that when they are sent, some of the transaction fees burnt. Okay, Ethereum has that feature. So if there is a lot of transactions, some of the transaction fee will start getting burnt. But if there are lesser transactions, you're also creating new tokens. So you can create all kinds of experimentation in that. And this is very beautiful, because till now we could only explore tokens, and monetary experimentation could not be done in real world. Okay, but here you can experiment all kinds of things, all kinds of ideas over a smart contract platform like Ethereum. And you can then have other smart contract capabilities, such as let me give you an example here, that you can have this smart contract capability here. It's a hypothetical scenario. Suppose when you're booking you're making a booking on an airline. Okay, you book a flight. Right now, it's not on a blockchain, but imagine you were using blockchain-based tokens, we were on the blockchain-based money, and you wanted to have a smart contract with the airline company. The moment you would book a flight, they would issue a ticket, you would make a transaction on to them, but the money would not be received by them. That money would can go to a smart contract, which is a code on the cloud, and it could lock and hold on to your money till your flight's departure date. Okay. Now suppose you have an agreement with the flight company saying that if my flight is delayed by more than 2 hours, then 50% of what you have paid should be refunded back to you. But if there is no delay, whatever you have paid, everything should go back to the airline company. Right now, we have laws, rules about it, but these are not implemented in smart contract terminology. Now, if you have a smart contract doing that, you can send this token. This token can be locked in a smart contract, means that contract requires maybe 2 out of 3 signatures to be released. Okay, 2 out of 3 signatures means one should be I should sign it, the airline company should sign it, and the smart contract itself, which can be connected with AI, which can be connected with certain conditions that will determine. So unless 2 people don't sign it, that money can remain locked in that smart contract. Okay. Now the smart contract is now what happens is the day of the departure of the flight comes in, the smart contract is already programmed that it checks. Now, how does it know if the flight is delayed or not? So every smart contract that we build on the blockchain needs data from the real world. So here, the smart contract needs to know if the flight really arrived or not. So maybe we can agree to use oracles. Oracles are third-party softwares that are connected to the real world. So maybe there are Oracle providers like companies like Chainlink. They are a source of Oracle providers. So oracles can check and see that if there is any sort of delay in the flight, it will record and send that information to the blockchain. The blockchain knows it's delayed. If it's delayed more than 2 hours, the blockchain basically it will sign that 50% of that amount should be sent to me, 50% should be sent to the airline company, and the moment I sign it, so now you have 2 out of 3 signatures done. So half of it will come back to me, and half of the funds will go back to the airline company. So this is one example of how smart contracts can work. But on the Ethereum blockchain, you can using these smart contracts, you can build very interesting decentralized applications, such as the whole of DeFi. DeFi is decentralized finance. All of the decentralized finance applications are examples of dApps built using smart contracts. Okay, so I hope this is clear now. What are the functions of these tokens? So I told you one function that was commonly used by many companies was ICOs. As Thomas already explained, how the ICO mania happens, how different projects start creating their own tokens, and most of them die out. But the good ones with community, with a project, with really some idea, they succeed. And so that's a bit of a speculation. This might change in the future. In future, you might have even companies putting their stocks on there, but for that you need certain kind of regulations there. In blockchain in the real world, we'll be discussing more about that. But ICO typically works like that. If I put a white paper and say I want to do this particular project, and I have the project can be a social cause, it can be a technological product, it can be whatever, and I say I will issue uh, a million coins. A million coins. Out of that million coins, say 25% are going to be kept by me as a company, because in future these coins can hold value. And say 75% I am selling it for the public. Okay. And I'm selling it to the public. Most of these ICO sales are done either in terms of Bitcoin or in Ethereum, because they are the holding value, or in terms of stable coins. And this is how companies raise money. Now, it's also it has other forms like IEO, where it's initial exchange offering, where instead of selling it directly, it's through a cryptocurrency exchange that this is offered, or IDO, when it's offered through a decentralized exchange, or ISTO is a security token, initial security token offering, which means it represents a um, equity in a company. For this, it requires certain types of regulations. So we will see this space also evolving. What else can you do with this creation of the tokens? Tokenization of real estates. Okay, so we discussed that. I know Florbella is very much in exploring this idea. So this company is very interesting, Solid Block. It allows for tokenizing of real estates, and these tokens then they can be sold. Now, do you do it on Ethereum? Ethereum is an option because Ethereum is one of the initial ones. Although Ethereum is the problem again is that it is highly used, so its capacity is limited. So its price of using Ethereum is higher. That's why you have other projects going on. There is another this very interesting project called Rally. Um, uh, it allows people who are either YouTubers or they have a community around that to create their own community coins. And this provides a way for monetizing of their own idea, whether you're a musician, so Alestra, she plays video games on YouTube, and she has a lot of followers. So she created a Ali coin on Rally, and then she can assign attributes. If someone, for example, a musician can say that if you want to come to my concert, you don't need to come and pay in euros or dollars. You can come and pay in my own currency, um, and uh, and then the fans also can buy it for speculation, because if the singer is more popular, maybe with time, as he starts getting more and more popular, the value of these coins might also rise. So there can be a certain speculative element and certain utility element. So what one of the interesting things with this tokenization is that all kinds of business models and cases can be experimented and explored. And earlier, often these artists didn't have much chance to actually retain the revenue themselves. Most of the revenue is taken by the record labels and the big companies they have to work with. Similarly, Chili's is a very interesting example of tokens that sports teams are issued. This will be again covered in more detail in future topics. And non-fungible tokens. So non-fungible tokens represent one particular item, or it could be a game item, it could be a rare item. OpenSea is one of the largest platforms for non-fungible tokens. It's been used by Dolce and Gabbana. It's been used by other platforms. So now we come to dApps. Okay, we talked about how smart contracts could be used to program uh, applications that are decentralized. Okay, so here we gave the example of Uniswap, SushiSwap. These are all examples of decentralized exchanges. So anyone can go and put their coins there. Now, decentralized exchanges use a concept known as liquidity pools to allow for instant swapping between two coins. So, for example, if you are swapping, if I create my own coin called Anish coin, I have not yet done it. I hope I do it sometime soon. And I hope you buy it. So if I create my coin, Anish coin, and I want to put it on a decentralized exchange, uh, now it needs to, so what will be the other end? Maybe I would say that maybe a stable coin would be something I'm more interested in. So maybe USDT versus Anish coin. So anyone can go and buy and sell Anish coin on the exchange. And so as people buy um, more Anish coins, as they buy Anish coin, the supply of Anish coin will reduce and they will pay back USDT. So USDT will increase in the pool. So the price will be dynamically fixed. As there's more demand for a niche coin, its price will eventually start going up. As there is less demand, if more people are selling a niche coin, its price will go down. So these decentralized exchanges are a fantastic innovation and a fantastic example of a DApp. Okay, this will be covered in your next class on DeFi, decentralized finance. Lending protocol, automated lending protocol. Now, what is interesting, just one thing I forgot to mention, is that these decentralized exchanges are codes in the cloud. So there's no person or company involved. There is a decentralized organization that's writing the code, but once it's deployed, it's there in the if the organization finishes also, the code will still remain there. So that's why it's impossible to censor them. So the same concept is used for decentralized lending. So Aave is an example here where borrowers and depositors can lend from each other. So it's a peer-to-peer lending, but it's collateralized lending, which means if I go and borrow some money, if I go borrow, I have to put some collateral. Suppose if I want to borrow USDT because I need dollars, I need to put Bitcoin or Ethereum as a collateral there. And if the value of my collateral falls down below the amount that I have borrowed, the protocol will automatically sell my collateral. So that way the lender can never have a loss in it. So that's an example of an automated lending platform. These platforms will eventually evolve. This will also be covered more in the DeFi. And then we come to Ethereum fees. So how Ethereum fees work? It's very similar in concept to Bitcoin. As there is more demand, there is limited block space. So in that limited block space, then if you want to, so you have to put it like we were putting a minor tip. Here it's called gas price. So you are going to choose what is the price for gas you are willing to pay. Now, the only thing in the difference here is in the case of Bitcoin, you are only making a transaction, but in the case of Ethereum, you are not just making a transaction fee. You can make a transaction fee whether you are sending ETH or whether you're sending any of the tokens. You can send a stable coin, you can send an ICO coin, you can send the coin for a project. Every transaction will have a transaction fee, but you can also implement smart contracts. So the smart contracts means there is some implementation of this execution of that smart contract on the blockchain, and that so you set a gas price, and the gas price will be multiplied by gas limit. Gas limit means how much of computation is required. So if you have a large amount of computation, if I have a very big smart contract, gas price will be multiplied by the gas limit, and uh, and that will give you the transaction fee. So if it's a simple transaction of a unit of a token, it will be cheaper. If it requires playing with the smart contract, like using a DeFi, like using a decentralized exchange, that transaction will be much more expensive because now it has more computation compared to a simple transaction. So that's why Ether's transaction fee is a little bit more complex than Bitcoin's transaction fee. But that is one of the big problems Ethereum has been having, is that because it got so popular, it allowed so many thousands of tokens to be created. Everyone can create a token and everyone can transact it, and then everyone is creating smart contracts on top of it. So that's why you have the base Ethereum blockchain, but it's getting clogged. It is getting heavy. In fact, this is my only concern about Ethereum, that it's getting so clogged, and but it tries to do so many functions. So what is its future? And so Ethereum has been moving to, right now the Ethereum we have is Ethereum 2.0. That future idea is to have many different shards. So that means many different blockchains of core layer of Ethereum connected to each other. But still, it is not going to have to be able to perform all the functions that it can. So what the solution has been proposed. So many different projects have come up with their own solutions. So many of them, they call themselves a layer 2 of Ethereum. they use something known as roll-ups. So there are two types of roll-ups: optimistic roll-ups and ZK roll-ups. I'm not going technically into what these roll-ups are, but what they do is, typically you have a state. So suppose I have so much of tokens in my wallet. Okay, I can transfer that state. So a roll up basically takes a snapshot of my current state at the base. It freezes my tokens there, and then it goes to a second blockchain. So this can be, examples are Optimism, Polygon, Arbitrum. These are all different examples, but there are many examples existing. Okay, these are the more common ones. So once my tokens, I have now migrated my tokens from my base layer of Ethereum to these chains. Now these chains in the blockchain trilemma, they have further compromised decentralization. They are more centralized. Okay, so in a way you could say more risky. If I'm dealing with very high value assets, maybe I would want to spend more and be on the base chain. But I can go onto these chains, and since they are more centralized, they are much faster. They are very fast. So, and I can do all my transactions there. I can, and then these can be also rolled down. So, so whatever changes take place when I want, then it can be rolled down to the base layer. So you will have then two main transaction costs in the Ethereum when you're rolling up and when you are coming back rolling down. But you may spend years without rolling back to the main. So this is the whole idea of scaling up Ethereum. So the Ethereum community is very large. It has a lot of developers and they are developing. So when you want to test your DeFi apps, what's interesting is all these Ethereum based layer 2 protocols, they are also compatible with the Ethereum virtual machine, which means if you have written a dApp on the base layer of Ethereum, that same program you can simply take and copy paste it, and it will work on your layer 2 solutions also. So that means that migration is very easy. So that's why, say you have an app like Uniswap, it can easily, it easily goes there. And so they have versions on the different layers existing. Now, what has also happened is that as Ethereum got congested, other layer ones appeared. Now, other layer ones, the idea is they don't follow the roll-ups. What they do is they are completely independent blockchain by themselves. They may have their different attributes, different parameters, different functionalities. So Solana is one of the fastest blockchains there. Cardano is also there. Cardano is one of the only ones that's also following a UTXO model like Bitcoin, but it's much faster. It has other series of trade ups. Polkadot is there, but what's happening is that if you want, you have some assets on layer one of Ethereum. So suppose you have layer one Ethereum and you want to move to another blockchain. There exists bridges. That's one of the innovations that's happened, that I can go, suppose I have a USDT, $1 of USDT on my Ethereum. And now I want to take it to Solana. I can go to a bridge. I can lock my $1 of Ethereum on a bridge, and that bridge will create a new coin. So it will make sure my $1 on Ethereum stays locked. And on the Solana network, it has now created a new coin, and I have transferred that coin. So this kind of bridging works there, and that's why you have things like USDT circulating all over in different blockchains. And the idea and the vision is that the future may have all these blockchains interoperable with each other. It's not about one blockchain winning, but it's about multiple blockchains existing, bridges allowing for swapping between tokens and so on. And even if Ethereum is the most expensive blockchain to use, there will always be all these other blockchains. But let's see, time will tell which blockchains survive, which blockchains die. Um, and then we talked about stable coins. So one example of tokens that are created on Ethereum can be the two most popular, biggest stable coins are USDT, Tether. We already discussed how Tether is a company outside of the United States backing most of these Tether tokens with US dollar short-term government bonds. Okay, that's US Treasuries. And then USD coin is by a company Coinbase, Circle, where Coinbase is one of the big participants of Circle. So US dollar coin, the Coinbase is a publicly listed company in the United States. So um, if you are if you want, you may choose which one is safer. USD coin may be are considered by some safer because it's a regulated company inside the United States. But then if you are working or operating in a jurisdiction that is sanctioned, you would rather like to stay away, because there has been cases where USD coin, USDC has been frozen when based on instructions of governments. USDT is a bit more hands off because it's not based in US. They can also freeze your coins on certain wallets. All they need to do is tell this particular wallet address I want to block. They can do that, but they have never done it. And because they operate outside, they are a little bit more uh, disconnected from the US government. So depending on your risk profile, you would choose one or the other. There are many other stable coins. I'm just mentioning the two more. And the biggest algorithmic stable coin is DAI, which is made out of a project called MakerDAO. This is a DeFi project. What this means is to create these stable coins, users need to go and lock in their um, Bitcoin or USDT or USDC or any other asset. They need to lock that so that this new coin can be minted. And and all these coins hold the value of one peg of one. So this uh, but that, compared to the asset-backed coins, the DAI's use is much reduced. Now it's now that you understand that you can have different cryptocurrencies, you can have different tokens, you can have crypto NFTs, and all wallet addresses are these hexadecimal numbers. So now you can understand why crypto is of global nature, because you can move any of these tokens anytime you wish from your wallet to another wallet to another wallet to another wallet, or you can move it to an exchange which has its own wallet. From an exchange, you can move it to anywhere else. So they are by nature global and global in nature. So I hope this has been a clarification of our uh, first week's class. And if you have any question, whether it's in oral form or it's in written form, please go to our Telegram channel, type your question, or you can just record your question, and I will make sure I will answer it. So please try to do that before Friday's lecture, because Friday we'll have a lecture on decentralized finance, and this is important that you have these concepts clear before you start with that lecture. So thank you.